Hello everyone. We have previously covered all the network theorems in our previous videos like Thevenin's theorem, Norton's theorem, KCL, KVL, superposition and maximum power transfer theorem. Today our focus will be solving the problems related to the network theory. This problem is from the previous year analog electronics exam at Calcutta University. So let's start. This is the last year question, CU 2022. Okay. Here the first question is state and explain Thevenin's theorem. Okay. I already have one video particularly dedicated to this topic. Okay. What is Thevenin's theorem? Thevenin's theorem states that any linear bilateral network, this is a linear and bilateral network, can be converted to a voltage source and a series resistance are equivalent. Okay, so this is Thevenin's theorem. And the next one is the state and explain the Norton's theorem. So what is Norton's theorem? Norton's theorem also the same as the Thevenin's theorem. Norton's theorem states that any linear bilateral network can be converted to a circuit with a current source parallel with a resistance. This will be Norton's theorem. Okay, and I already have the dedicated video on this topic. Please check those videos. So now we need to solve this circuit and calculate the load current IL with using the Norton's theorem. Okay, so we already know that in the Norton's theorem we can redraw the circuit to this one, the simplified one, with a short circuit current ISC and a parallel resistance Rn and the parallel the load resistance. Okay, now we already have the value of load resistance 8 ohm. Okay, we need to calculate ISC and Rn. So step 1 will be calculate ISC. To calculate the short circuit current, we need to replace the load resistance by the short circuit. Okay, so redraw the circuit. 2 ohm, 20 volt, 10 amps current, 2 ohm resistance and 1 ohm, and this will be shorted. This is shorted. Okay, and we need to calculate this current ISC. So what we need to do? Very simple, just apply KCL at this point. Okay, assume that the voltage at this point is V. Okay, and that voltage is higher than the all over other voltage in the circuit. Okay, why? As if we do so, then all the current will be outgoing from this node. So let's apply KCL at point A. We can write down V minus 20 by 2 plus V minus 0 by 2 plus V minus 0 by 1 minus 10 amps equal to 0. Why minus 10? As this 10 amp is the current source and the direction is inward. Okay. If we solve this equation, then we will get V equal to 10 volt. Okay. Here the voltage is 10 volt. That means this current ISC will be how much? ISC will be 10 divided by 1 ohm equal to 10 ampere. So we already got the value of ISC is 10 ampere. Okay. Now we need to calculate the Norton resistance or equivalent resistance. Okay. First step is the remove the load resistance. Okay, and replace the source by its internal resistance. In this case, we have one voltage source, one current source. Voltage source internal resistance is how much? Our voltage source is 0 and our current source is how much? Is infinite. So let's redraw this circuit. Short circuit voltage source, open circuit current source, resistance 2 ohm, this is 2 ohm, and remove the load resistance, and we need to see the resistance from here, or we can say that just connect a ohm meter as I show in my simulation video. Okay, this is Rn. Here we can see if a current is flow from this direction, then this current will appear here, and from this point it will divide it this branch and this branch, right? That means this 2 ohm branch and this 2 ohm branch is in parallel and both combination is in series with the 1 ohm. Okay, so we can write down Rn equal to 1 plus 2 parallel 2, that is equal to 2 ohm. So we already got the value of Rn is 2 ohm. So we can write down is 2 ohm. Now what we need to do? We need to calculate the load current IL. If we apply current division rule, then we can write down load current IL is the opposite resistance 2 ohm divided by total resistance 8 plus 2 multiplied by 10. That means 2 ampere. Okay. Now we already have the answer is 2 ampere. But how do you know that this answer is correct? Right? Just apply the KCL, as KCL is the simplest network theorem to verify any solution. Okay. So let's apply KCL this point. Okay. And if we get this value of IL here is 2 ampere, then it's verified. Right? So let's apply KCL at this point. We can write down V minus 20 by 2 plus V minus 0 by 2 plus V minus 0 by 9 minus 10 equal to 0. Okay. If we solve this equation, we will get V equal to how much? V equal to 18 volt. Okay. As V equal to 18 volt, what will be the value of IL? IL will be 18, here 1 ohm and 8 ohm is in series. So 9, that means equal to 2 ampere. Now you can see with the KCL we also got the 2 ampere, with the Norton we also got the 2 ampere, right? So that means your answer is the correct one, right? And here you can see that the KCL is only 2 line solution. So that's why I always told you apply KCL for any network theorem problem. If they didn't mention any other network theorem, here they mentioned Norton's theorem, that's why we need to use Norton's theorem to get the current. Okay, so let's go to the next problem. Now they told us here, determine Thevenin equivalent circuit between A and B. That means they just told here that this is the load resistance. Okay, so what do we need to do? We need to redraw or convert this circuit to the Thevenin equivalent circuit. How it looks like? A voltage source, we call it VTH, a series resistance, we call it RTH, okay, and a load resistance is RL. Now they already told here load resistance is 10 ohm and we need to find out VTH and RTH. Okay, step 1, calculation of VTH. Very simple. What we need to do? Remove the load resistance and calculate the voltage at terminal A and B. So let's redraw the circuit. 5 volt, 20 ohm, 1 ampere, 20, 10, 20, 5 ohm, and this is open. And we need to calculate voltage VTH in these two terminals. What we need to do? Just apply KCL. Okay. If we apply KCL, then we will easily find out the voltage VTH. Where we apply KCL? In this point. This point is point A, and we assume the voltage at this point is V. Okay. So if we apply KCL at point A, we can write down V minus 5 by 20 plus V minus 0 by 20 plus V minus 0 by 30 minus 1 equal to 0. Okay. Here you can see I assume these two resistance is in series. Why? As you can see here, this terminal is open, right? That means here the resistance is infinite. As the resistance is infinite, there will be no current flow through the 5 ohm resistance. That means the current coming from this node will go to the 10 ohm resistance and all of the current flow through the 20 ohm resistance. That means this 10 ohm and this 20 ohm is in series. That's why I write down is 30. Okay. So let's solve this equation and get the value of V. We can write down 3V minus 15 plus 3V plus 2V minus 60 equal to 0. That means V will be 75 divided by 8. Okay. Here V is 75 divided by 8. That means what will be the value of the current in this branch? That will be I equal to 75 divided by 18 divided by resistance is 30. That means 75 divided by 240. Okay. So this is the value of current flows through the 20 ohm resistance. Okay, we need to calculate the value of VTH. The value of VTH will be, as you can see, VTH and this one and the 20 ohm is in parallel, as there is no current flow through the 5 ohm resistance. So we can assume that here is the short. That means the voltage VTH is nothing but the voltage across this 20 ohm resistance, right? So we can write down VTH equal to 75 divided by 240 multiplied by 20. Okay, so this will cut, this is 12. Then we can write down VTH will be 6.25 volt. Okay, so we already have the data of VTH and this will be 6.25 volt. Now we need to calculate the value of RTH. This is steps 2. We need to replace the source by its internal resistance. So let's redraw the circuit. 20 ohm. This will be current source, that means open. 20 ohm. 10 ohm. 20 ohm. And here is the 5 ohm. And here, from here we need to see the resistance RTH, right? I already told you how to calculate this kind of resistance. Let's assume a current is flow from this direction, okay, and it's coming to this one. Then this current will divide in two directions. One will be this side, another will be this side, okay. Then this current will be divided this side and this side. That means this 20 ohm resistance and this 20 ohm resistance is in parallel, okay. So just calculate these two first. We can write down that these two will be how much? 20 parallel 20. Then it will be how much? It will be 10, right? And this 10 ohm is series with this one. So we can redraw this circuit like this. 10 ohm and just draw the rest of the circuit. I just make step by step such that you can understand. In exam, you don't need to do like this. Right? Now you can see this 10 ohm and this 10 ohm is in series. That means again it will create 20 ohm, and this 20 ohm is parallel with this whole combination is parallel with this 20 ohm, and this whole combination is series with this one, right? So we can write down RL will be 10 plus 10. This combination is parallel with this 20 ohm resistance, and this whole combination is series with 5 ohm resistance, right? That means we can write down 10 plus 5 is equal to 15 ohm. Okay, so we already have the value of RTH, or sorry, this will be RTH, not RL. Value of RTH is 15 ohm and the value of load resistance is 10 ohm, right? So here is 15 ohm. Okay, so if we redraw the circuit, go to the next page. If we redraw this circuit, then we can write down VTH how much? 6.25 volt. RTH how much? RTH is 15 ohm and load resistance is how much? Is 10 ohm. So we can write down IL, load current will be how much? Load current will be 6.25 divided by 25. That means 0.25 ampere. Okay, so this is the answer. Now let's go to the next problem. Here they ask, what is maximum power transfer theorem? Using this theorem, show that power transfer efficiency cannot exceed 50%. Just yesterday, I uploaded the video of maximum power transfer theorem. Okay, what is maximum power transfer theorem? Maximum power transfer theorem states that a circuit consists of VTH and RTH and the load resistance is RL. Okay, the power delivered from source to load will be maximum when the RL equal to RTH. This is for DC. Okay, for AC is different. Okay, so for DC, the maximum power transfer theorem states that the maximum power will delivered from source to load when the load resistance is same as the source resistance or Thevenin equivalent resistance. Okay, this is maximum power transfer theorem. And Here they told us that it is cannot exceed 50%, right? Let's assume R equal to RTH equal to RL. That means the current I will be VTH divided by 2R. Okay. So if we calculate the power, then we will get P source will be VTH voltage into current. This will be VTH square by 2R. Okay. If we calculate power at load, P load will be how much? The current I square VTH square into RL or R. That means R multiplied by VTH by 2R square. That means VTH square divided by 4R. Right? Now you can see the load P load is 50% of P source. Okay, that means when the maximum power is delivered from source to load, at that time how much power we get is the 50%. Here you can see is VTH square by 2R, and the power we got in the load is VTH square by 4R. That means 50%. Okay, for the detailed video, please check out yesterday's video on the maximum power transfer theorem, where I proved the theorem in the simulation as well as in the theoretical or calculation. Okay, let's go to the next problem. Here we have to solve a problem. It's coming in the CU 2019. Okay, this is a CU previous year question. Here they told us state superposition theorem for a network of electrical circuit. Right? I already explained this one. Using this theorem, find the potential drop across 5 kilo ohm resistance. That means we need to find out the potential drop across this one, right? So what is the potential drop across 5 kilo ohm resistance? Will be I. If I consider this will be I, then I multiplied by 5 kilo ohm. This will be the voltage across the 5 kilo ohm resistance. So we need to calculate the current across the 5 kilo ohm resistance. Okay. Now you can see in this problem we have two independent source. One is 18 volt voltage source and another is 6 milliampere current source. So what we need to do? First we need to consider one source at a time. Okay. So what we can do? Redraw the circuit by one voltage source. And this will be open circuit. Why this will be open circuit? As internal resistance Ri of a current source will be infinite. Okay, that's why I just make it open circuit. Now we need to calculate the current. Here I assume this one is I, right? Here I assume this will be I1. So what will be the value of I1? I1 will be 18 divided by 2 kilo ohm, 5 kilo ohm and 3 kilo ohm all is in series, right? In my Thevenin theorem video, I already told you how to calculate the equivalent resistance, whether it is series or parallel, right? Here you can see these three resistance are in series. So we can write down 2 plus 3 plus 5, right? That means I1 will be 1.8 milliampere. Okay, so we've already got the one current with the 18 volt voltage source, right? Now next go to the another voltage, that means only 6 milliampere. So step 2, 2 kilo ohm. So voltage source will be replaced by the short circuit. 6 milliampere, 5 kilo ohm and 2 kilo ohm, and here 3 kilo ohm. Okay, so the direction of current will be this side, this side, this side and this side. Okay, so what do we need to do? We need to apply the current division rule, right? So here I assume this current is I2. Okay, so I2 current will be applying current division rule in this particular node. Then we can write down the opposite resistance will be how much? 2 and 3 in the series, 5 kilo ohm. So 5 kilo ohm divided by what is the total resistance? Here 5 and here 5, that means 10 multiplied by 6. Okay, that means it will be 3 milliampere. Okay, so for the 6 milliampere voltage source, we got the current will be 3 milliampere, and For the 18 volt voltage source, we got the current will be 1.8 milliampere, right? So we can write down the total current I will be 1.8 plus 3 milliampere, that means 4.8 milliampere. Okay. Now we already got the current. Just put the current in this equation. We can write down V5, that means the voltage across the 5 kilo ohm resistance will be 4.8 milliampere, that means 10 to the minus 3 into 5 kilo ohm. Okay. From here you can write down it will be 24 volt. Right? Here you can see the answer is 24 volt. So the answer is matched. Okay. So it's very simple. Whenever you saw any superposition theorem problem, at that time, what you need to do? Just do the calculation with only one source at a time. Okay. And when you do the calculation at that time, replace the other source by its internal resistance and calculate the individual current or voltage. Then just do the addition or subtraction. Here they say, using Thevenin's theorem, find the current through 12 ohm resistance. Okay, that means here the load resistance is this one. Okay, so we can redraw this circuit and write down this will be VTH, RTH, and load resistance will be 12 ohm. Okay, first we need to calculate VTH. How to calculate VTH? Remove the load resistance and calculate the voltage across it. So, redraw this circuit is 5 volt. Okay, this is B, this is A. 24, 36, 24, 36. Okay, so we need to calculate VAB. This will be VTH. Okay, what we need to do? We need to calculate VAB, or we can write down VA minus VB, right? Just redraw this circuit and then we can write down the circuit looks like this will be 36, 24, 24, 36. This is 5 volt, point A, point B. Okay. This is 5 volt mean here we have 5 volt, here we have 0 volt. And here this branch and this branch is in parallel. That means 5 volt will apply here and also here. Right. So we need to calculate VA. VA mean the voltage drop across this resistance. So we can write down VA will be 36 divided by 60 multiplied by 5. Okay. And what will be the value of VB? VB will be voltage across 24. That means 24 divided by 60 multiplied by 5. Okay. So VAB equal to, just common this one, then we can write down 5 multiplied by 36 by 60 minus 24 by 60. It will be how much? It will be 5 multiplied by 12 by 60. That will be 1 volt. Okay. So VAB equal to 1 volt. That means VAB equal to VTH equal to 1 volt. Okay. Now we need to calculate RTH. For the RTH calculation, what we need to do? Replace the source by its internal resistance. That means short circuit. So just redraw this one. This is 24, 36, 36, 24. Okay. This is point A. This is point B. Okay. In this case, maybe it will little bit difficult for you to calculate the resistance. So what we need to do? We need to redraw the circuit. So first we need to start from point A. So we write down point A. From point A, I draw the line, and you can see from point A it's divided into two resistance. One is 24, one is 24, and another is 36. That means 24, 36. Okay. And then you can see this 24 go to this point and this 34 go to this point, and eventually these 2 points are the same. So we can just short this 2 point. After that you can see here it again divided in 36 and 24. 36 and 24. And then it joined at the B point. Right? Now we can see it's very easy to calculate RAB. Right? As here you can see 24 and 36 is in parallel and 36 and 24 is in parallel. These two combination is in series. So we can write down RAB equal to 24 parallel 36 plus 36 parallel 24. Right? That means we can write down 2 multiplied by 24 parallel 36 equal to 2 multiplied by 24 into 36 divided by 60. It will be 30 and then 10, 12. We can write down that means equal to 28.8 ohm. Okay. So now we already have the value of RTH and value of VTH. So we can write down that this VTH is 1 volt and this RTH is 28.8 ohm. Okay. So what will be the value of load current? Then IL will be 1 divided by 40.8. Answer will be 1 by 40.8 ampere. Okay. So let's go to the next problem. Calculate the voltage drop and power dissipated across RL in the circuit below using Thevenin's theorem. Find the value of RL for which power dissipated RL is maximum. Right? That means just the maximum power transfer theorem. You know, right? For the maximum power transfer theorem, that's that a circuit, the Thevenin equivalent circuit VTH, RTH, right? And this is load resistance. And they say the maximum power will delivered from source to load when RTH equal to RL. Right? Here you can say using Thevenin's theorem. That means we need to calculate RTH and then RTH will be equal to RL. And then we need to calculate the maximum power. Okay. So what do we need to do? First we need to calculate VTH. Here the load is RL. So we need to remove the load resistance. This is VTH. Okay. In this case, you don't need to apply any theorem or any case here. It's very simple, but you need to understand. Now you can see, just like in our last problem, here this is open, right? That means R equal to infinity at this branch, right? That means no current will flow from this circuit. So we can directly remove this particular part. Right? You understood? And then you can see here this is short and then a resistance. Okay? That means this path is 0. When current will come to this branch here, at that time current have two options. One is to flow from 0 ohm, flow from 100 ohm. What current will do? He will go with the low resistance path, that means 0 ohm. So no current will flow from the 100 ohm path. Or if I just apply current division rule, at that time you can see also I100 will be opposite resistance 0 divided by total 100 plus 0 multiplied by I if this current is I and this is equal to 0. That means no current will flow from the 100 ohm. Right? So what we can do? We can remove this resistance also. Right? Now you can see it's a very simple circuit where the two resistance is in series. Right? This 5 volt will divide it in these two resistance. So we will get VTH will be 2.5 volt. Why? As this two is the same resistance. So voltage will be divided equally. Okay? Or if you want to calculate, then you can calculate VTH equal to 10 multiplied by I, where I will be how much? I will be 5 divided by 20. Okay? It will be 2.5 volt. Very easy. But you need to understand the concept. Okay? So VTH is how much? VTH is 2.5 volt. Okay? Now we need to, what we need to do? We need to calculate the RTH. For RTH, we need to open this load resistance and short this path. Right? So redraw the circuit. 10. I already told you this is equivalent to short as no current will flow from 100 ohm. So just short circuit. And you can see here this 20 and this 20 is in parallel, right? So what we can do, just make it series 10 ohm resistance. Okay, and we need to calculate RTH from this one. Now it's very simple. This 10 ohm is in parallel, and this whole combination is in series with the 10 ohm. So we can write down RTH equal to 10 plus 10 parallel 10, that is equal to 15 ohm. Okay, so now you also have RTH is 15 ohm. So as per maximum power transfer theorem, the maximum power will flow from source to load when RL equal to RTH. That means RL will be 15 ohm. Okay, so we already got the value of RL, right? Now what we need to do, we need to calculate the value of voltage drop across RL, right? So here we have is 2.5 volt, and here you can see these two resistances same, right? So the voltage drop across the RL will be 1.25 volt. Okay, and what will be the maximum power? The maximum power P max will be VTH square divided by 4 RL. What is the value of VTH? 2.5 square divided by 4 into 15. That means 6.25 divided by 60 watt. Okay, so this is the answer. Let's go to the next problem. This is very easy. They just want to know the value of maximum power and the value of RL such that the maximum power is delivered from source to load. The maximum power will delivered when RL equal to RTH, right? How to calculate RTH? Just short the source, 3 ohm, 3 ohm, 2 ohm, 1, and we need to check from here, right? Here we can see that these two resistance is in parallel, okay, and this whole combination is series with these 2 ohm and 1 ohm. We can write down RTH equal to 2 plus 3 parallel 3 plus 1, that means 2 plus 1.5 plus 1, that means 4.5 ohm. Okay, so we already get the value of RTH. Now we need to calculate the value of VTH. Also very simple, just same as the last problem. Here we need to calculate the voltage, right? Here you can see from here the current will flow from this direction, right? But at that time it will find out that this branch resistance is infinite. That means, and you know I equal to Vy infinite equal to 0. That means no current will flow from this direction. Okay, so the current flow from source to this direction, and then all the current will flow from here and then goes to source to back. Okay, so that means we can just remove this two resistance. Okay, so the voltage VTH is nothing but the voltage across the 3 ohm resistance, and to be how much? The same as this two resistance is same, so the voltage will be equally divided in these two resistance. So VTH will be 9 volt. Okay, now they need the maximum power, right? So what is the value of maximum power? The maximum power P max will be VTH square divided by 4 into RTH or RL. Here 81 divided by 4 into 4.5, that means 18 watt. So this will be the answer. Okay, thanks for your time. Please do share this concept with your friends, and if you like this video, please press the like button. It is really means a lot for me. Bye bye.